All right, so we're live. We have Jeff, Ruth, Jesse, and Jamie, the whole crew. And we're going to get started with a prayer by Jesse. This is group 2 as well.
Our dear Heavenly Father, we're thankful for this day, and we're grateful for all the many blessings that Thou hast blessed us with, and may we ask for Thy help at this time as we are doing our last lesson of this class, that we will be able to understand the concepts and be able to help each other understand and to work together. And please help us as we are nearing the end of the semester, that we will be able to finish strong and have the energy and be able to recall all the things that we learned. And please watch over each of our families, and we are again grateful to Thee, and we pray for these things in the name of Jesus Christ. Amen.
Amen.
Your prayer must have worked already, because I think I'm already finished.
Okay, let's jump to the prep, look over that, and just a heads up, I'm not on my game today, so I'm down on the roller coaster right now.
What?
But I had an up week last week. That's good, at least.
Yeah.
Yeah.
I think your down week is better than my up week, so we're all right. We're
Okay, so did anyone have questions on part 1?
No, I think we're good.
Okay.
I'm good.
So we're going to use the gharial crocodiles data for the second part. And question number 3, check the 5 assumptions for conducting a linear regression on the data. List the 5 assumptions below and explain how you checked the assumption. Include charts, graphs where appropriate.
Can I just say that I didn't like this one?
You didn't what?
So I had trouble with the
Oh,
one. Let me pull this stuff up.
I'm going to share my screen with the chart. I could get there. Okay, so the first one was check the 5 assumptions for conducting a linear regression. So I went down the list of the 5 assumptions, right?
Mm-hmm.
So the first one was the scatter plot. Number 1 says between X and Y, there's a linear relationship. So then we go to this one right here. Oops, this one. And it's a hot dog shaped. It was positive. So it is a linear relationship, as you can see. Then I went to the second thing, which was the points of the QQ plot are close to the line. Whoops. It's this other one over here, right here. So they're close to the line, which they are. And then the third one was that it's not a megaphone slope in the residuals. So this is not a megaphone. So it meets the requirements.
See, I think I had all three of those that looked similar, but then when you check them against the
Data?
answer sheet,
Are they?
that it
Oh, I
didn't
haven't
look,
checked that.
it didn't look exactly the same on that residual one.
Did it have the same answers though?
Yeah, I got all the right answers you know,
Checking it off?
yeah, everything was right.
Well, that's weird.
So
Did
it looks
yours?
like you and I pulled it up the same way.
Okay.
Trying to pull mine up, my computer's slow. Computer's probably got too much on it from all the school. Hoping it makes it another 7 months.
Okay. Well, did everybody get?
I'm not there
Yeah,
yet,
what did you
so
others?
sorry I'm not
Yeah.
much help.
No, that's fine. Jesse, were you able to do it?
So yesterday I wasn't able to get much of this done because I'm actually out of town visiting a friend and their power. We had no power most of the afternoon yesterday, and then my computer died. So
Oh, that's frustrating.
yeah, I was like, of course it dies when the anyways. So I wasn't
Okay.
able to get much of this done. So
Okay, that's fine.
So on your scatter plot,
Yeah.
pull that back up and let me see your scatter plot.
Okay.
I actually have the residual one. The residual was the X and the Y, right? It was all over. Is that right?
It was that list on the side. I'll show you. I don't know how to explain it. Okay.
Yeah. By the X,
Yes.
you have your X and then the residual, right?
Mm-hmm. So this is what you're talking about, right? Okay.
Yeah, and that's the one in your or your charts that is all over, correct?
Yes. This one.
That
This
one.
is all over. Yes.
And then the one to the right of it is the QQ plot.
Yes.
And then up,
These of this.
right.
Yes.
And then so above it, let me see the scatter plot you have. Maps.
did you add these like yourself? Is that how you did it?
This one is the one I added this one so that it could be together in the same page. But these two you do here in the same page. These two.
The the scatter plot is at the bottom of it already, right? That's the
Right.
one that's there.
Right.
Okay. I can grab that across.
So is this one the same as mine?
Mine
Again.
is.
Okay.
The
scatter plot.
plot you're talking about?
Mhm. Okay.
Pull that up. I think I left it.
So were you able to do the residual QQ plot, Jamie?
So do we want to move on to 4?
No, I don't have any of it done.
Okay, so should we move on or should
Yeah,
we wait
you
for
guys.
you?
No, keep going.
Okay. You got it, Jesse?
I still struggle to figure out how to like do all the like insert the QQ plots and all that, but
Just go to the
Have to pull the other descriptive.
to do this one, you just go back up here and you put insert. Well, first you have to highlight this
I can't see what you're highlighting.
right here.
I
The
don't think-
residual
I don't think
column.
you're showing anything. Pull it up and show her.
Oh, I thought I was.
You're not showing. That's what I thought
Okay, I
you thought
see.
you were showing. Like,
Okay, I see. Is it showing now?
yeah.
Uh-huh.
Okay, so you go to this column and you highlight this.
Okay.
Then you go up here to insert.
Okay.
And then you go scatter plot. No. What do you do, Jeff? Hold on.
Sorry, I'm
Hold on.
inserting my.
I have instructions here because otherwise. Okay, then you highlight the residue, click the insert tab, click on scatter plot. Yes, click on the scatter plot with only markers, the first choice.
Okay.
Did you get it?
Uh-huh.
Okay, that's that one.
Okay.
Then the other one is easier because you just go to your other template. The very first template that we used, it has the QQ plot in there. And so you just put these numbers
Into it.
into it. But this one has formulas in it, so you have to do it as a value, copy as a value. I don't know about you guys, but oh yeah, Jeff said he was having a hard time. I'm having a hard time. Just trying to motivate
I pretty
myself.
much.
Wait, how did
Yeah.
Just go. I think it's built up anxiety that we're almost done.
Yeah.
I told you it was, I had turkey dinner and I was done.
That was weeks ago.
Yes,
Sounds
now you
about
know what
right,
I'm
though.
motivating myself the last 2 weeks.
2? Oh, geez.
I feel ya.
I started the motivation thing yesterday.
Well, then you're in good shape.
So when I do the when I do the QQ plot, I insert it onto the descriptive, and then it just shows like
You plot didn't it have it pulled up? Doesn't that one require two? Doesn't it have two things?
oh, I did it on the wrong one.
Pull it up.
Hold on, I did it on the wrong one.
The QQ plot, I think, is just that descriptive data.
The only thing is you're using the residual data. That's it. That's the only thing.
And then one though, where it's all over, don't you have to use both of those, right?
You kind of cut off a little. What? Is Jeff gone? Oh, there he is.
Kind of cut out. I'm not sure what you said, Jeff.
Yeah.
That's right. It wasn't worth anything anyways. You're good. I was just talking, the residual chart that you run takes the X and the residual to run it, correct?
Yes.
And the other ones, the scatter plot comes up when you're on that form anyways, and then you just drag the the residual over to the QQ plot to run it, right?
Okay. Yes. I think if I understand what you're saying, so the residual scatter plot, you highlight. Aren't you supposed to highlight both of them?
Yeah, both the X and the.
Yeah, but I think I told Jesse wrong then.
But the QQ plot only needs the residuals.
Right, but the other one is the one that I think I told her wrong.
And that was one of them that I had the question on, the residual.
Yes, you do highlight the X and the residual and go down. Sorry, Jesse.
Okay.
Highlight the X and the residuals to get that scatter residual plot. Okay. Should we go on to the next one then? Or how you guys?
Yep.
Okay. Let's see.
That's state the null and the alternative hypothesis.
Mm-hmm. So it's always the same, isn't it? I mean, it's kind of like the other, like the NOVA. It always, B1 always equals to 0, or B1 is not equal to 0. The second part is the one I wasn't sure.
Part B.
Yeah. What does that mean? It's just giving you information?
I don't know. It's like the third time they said it. There's nothing yet. It's just information.
Okay. Okay.
I have no clue. It just stated it right up in the question in 4. So
Yeah,
I
I don't know
why
why.
it did that. But.
I'm guessing that this is what I guessed. I guess they wanted us to write the p-value there, is my guess.
No, the p-value is right. I don't. It didn't. I mean, if you look at the answer key, because I stared at that and I'm like, okay, whatever. I don't know what.
What does the answer key say?
There's nothing there. It's just says alpha equaled 0.05.
Okay. All right. So
okay.
The test statistic and the values of the test statistic.
They had 22.675.
Yeah, and the test statistic is T, right?
Yeah.
Okay. So based on the, Jesse, are you following? Okay. Do you want to take the next one?
I did it. You got it, Jesse, go ahead.
All right.
Go ahead.
For number C, is that what we're on? D. Okay. Well, based on the p-value, do you reject or fail to reject the null? The p-value I got was the 5.0803 e to the negative 13.
Yeah. Which is super, super tiny.
Yeah. Yep. So I rejected the null.
Yep.
So E, state the conclusion.
We have sufficient evidence. Linear relationship between the head and the body length.
Yep. That there is a difference. There is a relationship. There's a linear relationship between the body. Yeah. Mm-hmm.
Yeah, because we were looking for the comparison of head to body.
Right. Okay. So number 5 is create a 95% confidence interval for the true slope of the regression line relating head length and body length. So what's that?
6.704 and 8.096.
That's what I got.
Did you put 6.704?
Yeah.
Oh, yeah. Uh-huh.
Yeah, that's what I got.
And 8.096.
Yeah. So how do we state it, Jeff? How do we state it?
No, you already stated it. So this was just asking for those intervals.
Oh, okay. It wasn't going to ask us to suffer with that.
No, you just did it before that. That was your suffering. State your conclusion.
Okay.
You already made it through that and you didn't even know you suffered. Way to go, Ruth.
Oh, no. Okay.
All right, let's jump to the quiz.
Jamie caught up to us. Good job.
Very good. You caught up to us.
I got a thing or two.
Good job.
I wish all of our homework assignments over the last 13 weeks were like that.
Let's see.
Other than asking me a question that had no answer, so I stared at it for 15 minutes. Like, what am I missing?
Oh, that's funny. You know what? I ended up just putting the p-value there because I didn't know what to do there.
Well, you did something.
Yeah, but the answer was nothing.
Yeah.
So I got
that's
it.
why I got frustrated with it and pulled the answer key up at that point. Let's see.
Okay. Does everyone have the quiz up?
Yeah, I'm almost there.
Not yet.
I'll take
All right.
3 just because I feel like I can actually answer that one.
Well, the sad part is we're probably all right there with you. So thanks a lot for taking one for the team, Jamie. I was going to volunteer to do 1 and 2, is what I was going to volunteer for.
Yeah, those ones are the hardest of them all.
Yeah.
Okay, is everyone up yet?
Yeah.
No, my computer is being really slow.
Mine's not too far behind you, Jesse.
Just holler when it's up so I don't keep asking.
Sorry, I'm trying to hurry.
No, you're good.
Oh, you're good. So better pull that estuarine crocodile junk up.
Okay, sorry. It's up now.
Okay. So number 3, the true linear regression equation is that B0 and B1 are unknown. What are the null and alternative hypotheses for B1? So I believe it's the third one, equal to and not equal to 0. And if I'm wrong on this one, I got no hope for the rest. So
No, I think you're right.
No, I think you're right because we don't know it, so we can't say greater than or less than.
Okay. So who's going to take the next one?
I can.
Go ahead.
Go. Sorry. A residual is I say it's the difference between the observed value and y and the value that would be predicted. So the third one.
yeah, that's what I would say as well.
Okay. A plot of residuals supports using linear regression when
I saw that.
the first one.
Yeah, it'd have to be distributed normally. To be linear, right?
Yeah. Okay.
For the information, for the next 8 problems,
Okay, so now we have to put these things in.
use the data in math self-efficacy. Use the confidence variable as the explanatory variable and the score variable as the response variable. This is explanatory. 6, compute the residuals for the data using software. What statement best describes the residual? I don't think I downloaded this one.
So on this, it looks like confidence is the first one then?
Confidence is explanatory. So,
Okay.
yeah, I'm guessing that.
Sometimes I get mixed up when they're.
Me too.
Yeah, this one told you though straight.
Yeah.
It was explanatory and the score is the response. That nice on the test.
Yeah. Well,
I have to say that this test coming up is the one I feel least prepared to take. So.
yeah. So would this one be, it's a linear pattern?
Coming up, so I haven't even gotten to it yet.
Yeah, because it's a hot dog shape. Oh, wait a minute. Isn't it talking about the residues?
Yeah.
Are we supposed to do a residual chart?
So in the residual chart, that's with the X
And the,
residual?
yeah. At least that's what I'm understanding. I don't know if that's right.
Okay, if I did the right chart, that one isn't very hot dog.
Yeah, it's the first one.
Like, doesn't it already give us the graph?
Well, see, that's what I mean. Is that what it's talking about? That's what I want to know. What do you guys think? Because
I'm just catching up here.
Because the residuals, we know they're definitely between -40 and 25. It seems.
okay. So it's not number 3.
True. Process of elimination.
Right. And then you said the residuals are between -4 and 25.
So I think it is that one. I think it's the first one because we know that one. If we look at it, like that one's for sure. So whether or not we're using the right linear pattern, the right chart, I don't know if that matters because, you know, it's the first one applies.
I think they want it more basic. I do think they want the second one. But I don't know. Jeff?
Okay. I can join. I just got my thing done. So
Okay.
compute the residuals.
Jess, you got
Compute the
yours
residuals.
done?
What are the data using software? What statement best describes the residuals?
Oh, best describes.
Residuals form a linear pattern, which is true. That would be my choice, probably.
Are you applying the math data or are you just applying knowledge residuals?
No, I'm looking at the data. So I don't know what everybody's looks like. I'm assuming that it all looks the same. But you run it. I've got the line running through it. So I mean, it is residual. It's going right through the middle of it. A linear. And it was -40 to 25, right?
Yeah. I'm going to share my screen. So is this one right here is the residual chart?
Yes.
Okay.
So
And then for the QQ plot, we're just using the residual?
What can you say about these residuals?
yes. So that we would go with 2 on 6.
Yeah.
And basically keep on. QQ plot should look similar to the.
So, based on the QQ plots for these residuals, what can you say about these residuals?
Does it have one that says I'm lost?
What did we conclude for number 6 then? Sorry.
The second one,
Okay, that's what I
the
thought.
linear
Sorry.
pattern.
What about number 7? The residuals are fairly normal.
You mean? Let's see.
What?
Yeah, I would say it's the second one.
Are you reading the book? Were you checking out the book?
No. Mine are totally right on the line.
Oh, okay. I thought, oh. Wait a minute. Oh, I didn't do the QQ plot. Okay, I see what you're doing. Darn it. Okay.
You flying somewhere else, Ruth?
I'm plotting something else. Okay.
Plotting your trip to Hawaii for Christmas or something? Is that what you're doing?
Oh,
Sounds
nice.
about right.
If you are, I vote that we give up on this and let's start plotting that.
That's a good idea. Okay. I see.
So, I mean, I would say 99% of my data is on the line.
Okay.
Pretty close.
Oh, yeah. Okay. So should we go on to number
8.
8?
I'll read this. Use software to create a scatter plot of the data. Given this scatter plot, residuals plot, and the QQ plot, which of the 5 assumptions about linear regression are satisfied by this data? Check all that apply.
All of them do. So let's see.
So there is a linear relationship.
Yes. Variance of error term is constant for all x's. Yes. The residuals are normally distributed. Yes. The the x's are measured
Bless
with
you.
our error. That's true. And I think the only one that's not applicable is the last one, right? No. Are we Xing them all? Let's see, 1, 2.
Oh, it's the variance of error.
1, 2, 3. 1, 2, 3, 5.
Someone's going to have to explain the second one to me. I have no clue what that's.
That would be, I think it would be on the 4th one. The fourth requirement on the table,
Let's see.
the x's are known, are constant.
Constant. The x's are known constants.
Yeah.
Cannot be checked directly. X's should be measured accurately, precisely. Let it check. Cannot be checked directly.
But I don't, okay. Hold on. Are they tricking us? Probably.
Probably.
Of error. The variance of error term.
So let me see if I still have the book open. Go back into it. That was the one that's
I
not.
think you're right. I
wrapping
think that's
it
not
around.
one of them.
The second one.
Yeah, I think because it says
I
the,
just the wording on it is weird.
yes, the variance. You said the variance, and that's, I don't think that's right. The variance of the error term is constant. The x's should be measured. I think that's it.
So the variance of error terms is constant for all. Yep. So it is. That's on.
That is correct.
Yeah, that's number 3 of the 5. The variance of
1,
error
2, 3.
terms is constant for all values of x.
That's number 3.
There's a root.
Oh, yes.
Yeah.
The variance is constant. That's correct.
So it looks like it is all of them.
The observations are independent. The x's are fixed and measured without error.
And the observations are dependent.
It's normally distributed and linear. So what do we got? Linear, variance, residuals, and measured without error. Yeah, I'm gonna guess it probably is all of them.
Yeah. Okay.
And then what is B1? Is that 12.695?
Yep. Up to 95% confidence interval for B1. Lower down the upper bounds, lower 10.674.
Yep.
Come on, computer, join me with us.
14.715.
Now construct.
I'm gonna guess I have the same thing. 715.
Are we, where are we? The
On the
confident
upper and
level?
lower bound, 10 and 11.
Okay, so would the lower bound be 10.674?
Yep.
Okay. The upper bound 14.715.
Yep.
What decision would you make regarding this test? We are going to. We're going to fail to reject. Right. Reject.
Are you rejecting the null?
Yep.
So the third option.
Oh, it's the 3, so it's pretty small.
Yeah, it's 20. It's 24 negative. So.
Right. Yeah, it's pretty small.
Yeah. So the third one is right, Jesse. You reject the null hypothesis. What does it mean? If that's not a clue, right?
What does it mean?
There is sufficient.
Yeah.
So it's sufficient.
So 2 or 4.
So it's the third one. No, wait.
No, it should be
No,
sufficient.
2 or
you're
4. There is sufficient evidence to conclude this. Both of the regression line is 0.
Oh, you just go
Wouldn't
back
it-
to the. Go ahead,
Wouldn't
Jesse.
it be insufficient? Because when you're rejecting the null, then we have sufficient, but if we're failing to reject, it's insufficient.
But we're rejecting.
Yeah, we're rejecting, so it's 2 or 4.
Yeah, but it says. Oh, yeah, just kidding.
Yeah.
That
No, you
is
said
true,
it.
though.
You just told us. You just told me. This is true.
I totally my brain switched it. So
Said it right.
okay, thanks. Thanks for making me feel good in a stupid moment.
No,
Yes.
it's not a stupid moment. It was the brain not catching up with where you were standing. So you're good. So what does the 0 have to do? That's in the 5 thing.
You just
Right.
have to look at the alternative because that's what we're referring to. There's sufficient evidence to conclude, and what does the alternative say? That it is different than 0.
It is equal to 0.
So the last one.
Yeah, that's what I would say.
If we're rejecting, that's what we're going.
Mhm.
Because it's equal to 0 or not equal to 0, right?
Correct. Mhm.
So there's sufficient evidence to conclude that the slope of the regression line is not 0.
Okay. And then on 14 for this data, which variable is the dependent variable? Well, if we look up top, it says head length was used to predict body length. So we know body length is dependent on head length.
So body length is the Y, and the head length is the X.
You said 14 was body, right?
Yeah.
Because that's the one that's depending on the head.
Yep.
So I'm sorry. So the X is head length. I mean, 14 is head length.
No, it should be body length because it's dependent on the head length. Because the information tells us that the head length was used to predict body length.
So how do you clear your data out? Do you just delete it?
Yeah, just highlight and delete.
I have not been able
Head length was used.
to
Head
spruce my stuff up.
I think
Good point.
to protect. So then dependent variable is the x. Are we talking about the x here?
Mm,
Yes, dependent variable. I still think it's the
Isn't
head.
wait, is the dependent variable always x?
Yes. So I think it's still the head because the head's not going to change. The head is what we're using to predict the body. So I think it might be head length. Because I have a little note. I have a little note here.
Because we're dependent on the head length to get, maybe I just have, I don't know.
Okay, so I made a note of the crocodile thing because that was confusing me. So I wrote that the X is the head length because it's using to predict. It's being used to predict. So it's the dependent. And the Y is the body length because we're trying to predict that.
So what's that called then? So X is dependent. What do we call Y?
It's the variable response. The response variable. Oh, wait. Explanatory variable is independent variable used to predict the response variable. So the dependent variable. You're right. I think you're right. Dependent variable is equal to Y variable. I think you're right. Yep. I think you're right, Jenny. Sorry. It's just I need to be okay with it.
Yeah, that's great. Double check.
Okay. So should we keep going? Now construct a 95% confident interval for B1. Put your answers for the margin of error lower bound. Oh, again? Oh, we were supposed to be doing this.
Sorry.
So what bounds do we use to determine the margin of error? Are we using Y or slope or what?
I'm not even there yet. They're asking us for the margin of error?
Yeah. But if we remember back to a few weeks ago, if this is how we determine it, isn't it the upper bound minus lower bound divided by 2?
That's how I remember it.
But I just don't know what the upper and what the lower is.
Well, we'd be using
and I would probably say
the slope.
Yep.
Use the slope.
Okay.
One. Yep, the confidence interval in B1.
Okay.
Yeah, I'm with Ruth. I had to close out, so I'm still waiting to put my body numbers over.
Okay.
I think is on a date with Jesse's.
Yeah, they're checking out. I got 0.4425.
So what is the equation? The upper minus lower divided by 2?
Yeah.
Okay.
I had to get out again. Unlike Jeff, I had to get out.
They're all having
Oh, computers are done for this semester.
Sounds like mine's missing out on a party.
Oh, you don't want to do that.
You have fun with that. We're gonna go finish our party. Hey, I joined you.
I had to get out because this thing was going cuckoo.
What'd you have? 7.218 and 8.13?
Yeah. 103.
Yeah, 8.103. Sorry. That's what's there. I just can't read.
Yeah.
Zero 0.4425.
Yeah.
You got 0.4425?
Mm-hmm.
Okay. And it doesn't say anything as far as what we're supposed to do.
I think on the last one, isn't it? We are 95% confident.
Those.
First.
I just count those wrong every time I come to them. I don't.
So the option is we are 95% confident, or there is a 95% chance, but it's not the chance one, I don't think. Or there is insufficient evidence to reject the null hypothesis.
What can you say about B1?
So did you guys get 0.4425 for the margin of error?
Yeah.
Yeah. I'm serious. I get these problems wrong every time.
The last one.
Yeah. Then I look at it and think I have it down and miss it again.
Did you guys put all four digits?
Yeah. Because it doesn't specify.
Except for at the top, it says when calculating anything, please remember to round to 3 decimal places unless otherwise specified. So we might want to change that.
Where was that at the very top?
Yeah.
In this case, 95% confidence in it.
If that's wrong because I rounded, I'm going to be mad.
The only thing that's crazy is usually it tells you, but yeah,
Right.
you paid attention right up top.
But it's always said that, and we've done it before.
Yeah. What are you guys thinking for 18?
I was trying to look it up and see if there was something in here that.
I haven't read it yet. I'm almost done putting the last digit in. Okay. Let's see. Based on lower and upper.
So did you put 0.443 then?
Yeah.
What can you guess? Based on your lower bound and upper bound from the last bound. What can you say about formula? And B1 is talking about the slope. What do we say about the slope? Okay, we are 95% covered. That the true regression slope P1 is between upper and the lower. Okay.
Let's see. What does it say?
I don't think it's number 2.
The chance one.
Yeah.
I don't think so either.
It's gotta be 1.
So with the p-value, we are going to reject the null.
Has to be 1.
I'm thinking 1, but I wanted to eliminate the last one. Why wouldn't it be? Sufficient evidence. Yeah, I think you're right. I think it's 1.
Mm-hmm. 16 out of 18. It is the first one on 18.
You already submitted? I can't submit.
Yes. That's something we should know, obviously. Okay, we missed 8, so it wasn't all 5. Something in there's not right.
I can't submit mine. Oh, there it is.
6 and 8.
Ah,
So 6 is obviously residuals between 40 and 25. 1, 2.
Oh, Jamie was right. You're right,
That's a
Jamie.
bummer that we lose all points on question 8. It should give us like half or something. I don't think none of them were right.
So which?
So my friend is taking the same stats class, just a different teacher or whatever, and it gives them it like shows them the correct answer if they missed it.
No kidding.
Yeah.
How come we have a different test?
No.
Can they take it twice?
Yeah.
That's
So we probably learned a
doesn't-
little bit more.
Yeah, I'd say that's probably not. Yeah, that's not great for you because then it's easy to just go back and put in the right answers. You know?
Right.
Okay, so do we want to?
Well, we know what 6 is, so 8 is the only one that we have a question on.
Right. So I'm thinking, let's go back to the book. Let's see. Between Y and Z, there's linear relationship. I think that's correct. Linear. Number 1. Yes. Number 2. I think it might be the number 2.
Yeah, the one we were questioning.
Yeah, but I'm still checking.
It's probably like one word off or something.
No, I don't think it's 2 anymore.
2 uses the exact same words in it, but.
I think it's number 3. The X values or number 4, one of those 2. Okay, not number this one, not this one.
Have you come back and look and see if you're screaming at us, Jesse?
Can you, so you can hear us fine? That's weird.
Doesn't that stink when you're screaming and no one can hear you?
At least not us.
Yeah.
What about check number 1, 2, 3, 4. Number 4. That's
The
kind
X
of.
values are measured without error.
Mm-hmm.
Normal error time. Constant variance.
No.
I'm going to stop the broadcast.